So, today we will demonstrate another experiment using the spectrometer and prism. So, this experiment is draw angle of incidence versus angle of deviation, not angle of minimum deviation, this curve of a prism for a particular wavelength of light. So, let me show you the how to do that. So, now I have to put the prism, So, this is for a particular, so this experiment is for a particular wavelength. So, here this is the source, that source we have taken, that is the sodium source. So, here yellow light we are getting sodium D line. So, it has a particular wavelength. Now, I will put the prism on the prism table. So, this apex of the prism will coincide the center of the prism table. Okay. So, now first what we will do, we will set it for minimum deviation. So, for minimum deviation I have to find out. So, I will unlock this telescope, and move in the other direction. So, let me so remember that we have taken the direct reading. Okay, we have taken the direct reading. So, this vernier should not disturbed, it should not rotate. So, that means this prism table with vernier we cannot rotate. Okay, we should not rotate. So, then reading will change. So, we should lock this prism table. Okay, we should lock this prism table. So, I have locked it. Okay, and this telescope, that is the unlock. So, I can move telescope, but I cannot move the vernier prism table attached with vernier. Okay. So, prism table have two options. You can rotate the prism table with vernier. So, if you rotate this one, so that I have locked. Okay. And without rotating the vernier, only prism table I can rotate. You can see this is fixed. Okay. So, we will use this one. Okay. We will rotate the prism table without rotating the vernier, because that I cannot do, since I have taken the reading, direct reading. So, only reading will change due to the rotation of the telescope. So, with reference to a particular position of the vernier scale. So, I cannot disturb the vernier scale. Okay. Now, I will set this prism for minimum deviation position. So, I have to set for minimum deviation position. So, this is the base. Okay. So, light is falling on this refracting surface. So, light will fall on it, and then one part of the light will be refracted, and this refracted rays always goes towards the base. So, for refracted rays I have to look towards the base. Okay, I have to look towards the base. Yes, and I will try to find out the minimum deviation position. I will rotate prism. yes, I got the image. Okay. Yes. So this is the minimum deviation position. If I rotate this way, it is going right side. If I rotate this way, then it is at minimum deviation position. If I continue the rotation, so it is also going this way. Okay. So I set it at approximately at minimum deviation position. Okay. So then I will bring the telescope at this position. I will bring the telescope at this position, and yes, okay. So, so this I have set at the minimum deviation position. Why I have set the at minimum deviation position? Actually, what we will do, so this is the incident angle for minimum deviation position. Okay. So I will not take this reading, say, because minimum deviation position I want to find out from the curve. Okay. So what I will do, I will so whatever the incident angle, for this incident angle, approximately this is the minimum deviation position. Okay. I can take this reading or I may not take this reading. What I will do, I will increase. So this is the normal, you know. So now, and this is the incident rays that is fixed. Now normal is this. Okay. It is attached with the prism, this normal, right? Now, if I rotate this, towards, if I rotate towards anti-clockwise, so what will happen? So this normal will go towards the incident rays. So that means angle of the incidence will decrease. Okay. And if I rotate clockwise from this position, then what will happen? The angle, so this normal will rotate this way. Okay. So angle of incidence will increase. So what I will do? So approximately, I will from this position I will increase or decrease by 2 degree, approximately 2-3 degree. Okay. So for both position I will take the reading, then again I will further I will increase by 4 degree in both side. Okay. 6 degree from both side, 8 degree from both side. So that way this is the approximate rotation. Okay. So incident angle for different position, incident angle that we will calculate. So we will look for each step of angle, we will look for the refracted rays and reflected rays. We take the reading and then basically we will get the deviation and incident angle. Okay. So this way one can do, or what we can do other way. So this is the minimum deviation position approximately. So now I will decrease the decrease the angle approximately by, say, some 10 degree also. So and then that means I will take the incident angle, some small value of incident angle. From there, step by step, I will increase the incident angle, then I will cross the minimum position, and then further I will increase. So, basically I will increase the incident angle and take the reading. So, I think I will decrease the incident angle by say 10 degree approximately. So, this is the normal. So, I have to rotate anticlockwise, and I will change and look at the uh, uh, refracted rays, because I should not lose this one. I am changing the angle, yes, as far as possible. Yes, that's the maximum change I can do, because after that it is going out of the view. Okay, maximum up to this I could do. Okay, so now this is the minimum incident angle. So I will start experiment from this position. So I will take the telescope now at this point. Yes, I can see. So I will fix the telescope. I think it's I am facing difficulties to slightly. It's fixing slightly. Okay, tricky. So yes. So I will tighten it. Okay, I will tighten this telescope. Now I will use this fine screw to make the spectral line coincide to the cross of the crosswire. Okay, so what is this position for a particular incident angle? What is the incident angle? I don't know, but starting from the minimum deviation, I have kept at present. I have kept the incident angle, small incident angle. So this is my starting point, and then I will increase the incident angle step by step and do the experiment. So for different incident angle, I will note down the deviation. Okay. So now this is obviously refracted rays. Okay, this is obviously refracted rays. So according to this one, so I set a particular incident angle, approximate angle. So for that, so reading for the refracted rays, so I have to take main scale reading, vernier scale reading, total. Okay. So 2-3 observation, at least 2 observation one should take. So what I will do? So for this refracted rays, I have to take the reading of the vernier 1. I am not taking reading. So I will note down. So for vernier 1's main scale reading, and then vernier scale reading, then total I will note down. Okay. Similarly, for vernier 2, I have to take reading. So for vernier 2, I have to take reading. So I will note down. Okay. Then again, just you try to set. Again, you try to set more accurately possible. Just, and then again take the second times this reading. Okay, second times this reading for vernier 1 and vernier 2. So for vernier 1, find out the mean R1. and for vernier 2 find out the mean R1. Okay. So now I have to take reading for this incident angle. I have to take reading for the reflected rays. Okay. Now reflected rays. So this is the refracting surface. So one part is refracted and another part is reflected. So I have to look for reflected rays. So with bare eyes, first I should see the that is the base. So this is the minimum angle as I told. So it's almost, it will be close to the normal to the yes, I can see. It will be close to the normal to the prism. Okay, prism means on this face. So I can see from here. So I will unlock this telescope, then move with bare eye. I have seen. Now I will place it here. Okay, I will place it here. Yes. So then I will lock the telescope. I will lock the telescope. Where is this? Yes, I locked the telescope. Okay. So then I will use fine screw. I will use fine screw and set at the cross position of the crosshair. Yes, I have set. Okay. So this is the position for the reflected rays. Okay. So now I will take reading for vernier 1, I will take reading for vernier 2, then I will note down. I will note down for vernier 1, for vernier 2, I will note down the reading. Okay. Then you take the second time, okay, just again try to adjust and get better position coinciding with the crosswire. Okay, take the second set and find out the mean. So this is R2. Okay. Now from here you can calculate this. This you can fill up the later on. Okay. So this R2 and R0 direct reading R0 from the table 1. Okay. From table 1, so whatever the R0 you should, I think, note down somewhere. R0 equal to note down somewhere here. Okay. So you take R0 and minus from R1, minus from R2, and then here 180 minus that R2 minus R0 divided by 2. Okay. So that will be the, so then you are getting accurate incident angle, and for that what is the deviation you are getting. Okay. So this is for a deviation for a one incident angle. Now I will change the incident angle. In which direction I will go? So I kept this incident angle as the at smaller angle. Okay. Now from here I will increase the incident angle, means I have to all the time I have to rotate, because this is the normal. So I will rotate clockwise. So normal will come this way. So this angle will increase, because this incident rays is fixed. Okay. I am rotating the prism table by approximately 2 degrees, say. That I can do, okay, because I should not disturb the vernier. So only I have to rotate this table. What I will do, so I will look at the refracted rays, then I will not, it will not be missing. So I am now increasing the incident angle approximately 2 degrees, say. Yes, okay. I have changed it. Now, I will repeat the measurement. I have to unlock the telescope. I have to unlock the telescope. I will take the telescope at refracted rays. I will take the telescope at refracted rays. Yes. Yes, it is at the refracted rays. I will lock it. I will use the fine screw. Okay. Take the reading for vernier 1 and vernier 2. Okay. So, for refracted rays, take the reading for vernier 1 and vernier 2. Again take the second times. Okay. Repeat, repeat. Okay. Then I have to go for the reading for the reflected rays. Unlock it. Go here and check the reflected one. Oh, I have to look. It's the yes, I can see now. I can see now. Yes, I set it here. Okay, locked it. Use the screw, fine screw. Okay, to find movement of the telescope. Take the reading. Take the reading for second incident angle. Take the reading for reflected rays. Okay, same way you take the reading for vernier 1 and vernier 2. Then second times you take, okay, and then find out the mean value. Okay. So, this way you continue for, now again I will change, the incident angle increase. I will increase the incident angle by approximately 2 more. Yes, okay. Repeat the experiment for refracted rays and reflected rays. Take the reading, okay. Take the reading, complete it. Then again I will change further 2 degree. Yes, take for refracted rays and reflected rays the reading. Then I will continue the change. Yes, I have changed. Again repeat it. Then I will change. Now it is started to reverse. Now refracted one start to reverse, means I am approximately at the position of the minimum deviation. Okay. So, I will change, it is now moving this other way. Okay. So, now this angle is higher, is greater than the angle of the minimum deviation position, incident angle basically. Repeat the experiment for refracted rays, reflected rays, you take the reading. Then I will continue for second position, not second position, for second higher angle from the minimum deviation position. So, this way at least 4-5 reading you take, then I will go for next step. Take the refracted and reflected one. Okay. So, this way you take as much as possible you can. Okay. For this position again repeat the experiment, then this position again you repeat the experiment, then this position again you repeat the experiment, then this position. Yes, it is now out of the field, I cannot go up to this. So, up to this I can. So, you can take at least 3-4 reading at the smaller angle of uh, angle at minimum deviation, and 6-7 reading at the higher angle than the minimum deviation position. Okay. So, complete this table, calculate the minimum deviation, calculate the minimum deviation. Yes. So, here basically you are getting for vernier 1 and vernier 2, okay. Deviation from vernier 1, deviation from vernier 2, incident angle also from vernier 1 and vernier 2. So, here you are taking basically this reading will this should come similar. So, mean of these two you are taking here. So, for a particular angle you are getting, for this angle you are getting mean deviation, for this angle you are getting minimum deviation, for this angle you are getting. So, this way you take at least 10 reading. Now here next table for drawing graph, So, from this table 2, so you know the incident angle and then the corresponding deviation. It is not minimum deviation. So, you just note down them here, okay. Now, your task is to draw. So, this is the incident angle theta I and this is the deviation, right. So, you plot it for, it is the smaller angle as I told, then I increase the angle rotating the prism, right. So, you will get this type of data, you will get. Okay, and you connect them. Actually, you should not connect, you should draw a smooth curve, right. So, these are basically your delta means deviation versus incident angle curve, right. So, now from there you can find out the just this is the minimum deviation, okay. You draw a line, so this will be minimum deviation and corresponding angle will be say theta I0, right. So, if you get theta I0, so as I showed you that you can calculate the angle of prism, using this one 2 theta I0 minus delta n, or you can find out the angle of the prism just doing the experiment, okay. How that already I explained. So, this apex you have to put towards the collimator, okay, and this base just opposite. Now, reflected from this face and reflected rays from this other face. So, take reading, moving the telescope, take reading for this both reflected rays, and half of it, whatever the angle you will get difference, half of it is the angle of prism, okay. So, that way also you can find out A, and then you calculate the corresponding refractive index, okay, because del m and A is known to you, and you calculate the refractive index using this formula, okay. So, this is a very nice experiment, and how to find out the refractive index using the delta theta I curve. So, this is the another way to find out the refractive index of the material of the prism for a particular wavelength. Here, this refractive index for sodium D line wavelength is 5893 angstrom. Okay. So, I will stop here. Thank you.